In the first video on evolution, I gave the example of the peppered moth during the Industrial Revolution in England, and how before the Industrial Revolution there was a bunch of moths. Some were dark, some were light, some were in between. But then once everything became soot-filled, all of a sudden the dark moths were less likely to be caught by predators, and so all of the white moths were less likely to be able to reproduce successfully. So the black moth trait, or that variant, dominated. And then if you came a little bit later and you saw all the moths have turned black, it's like, oh, these moths are geniuses. They appear to have somehow engineered their way to stay camouflaged. And the point I was making there is that, look, that wasn't engineered or an explicit move on the part of the moths or the DNA. That was just a natural byproduct of them having some variation, and some of that variation was selected for. So with that example, that was pretty simple, black or white. But what about more complicated things? So for example, here I've a couple of pictures of what's commonly called the owl butterfly. And what's amazing here, and it's pretty obvious if I probably don't have to point out to you, is it looks like its wing looks like half of an owl's eye. I mean, I can almost, draw a beak here, and draw another wing there, and you can imagine an owl staring at us, right? And here too, I can imagine a beak here, and you'd think an owl, and there too. And so the question is, how does something this good show up randomly? Right? I mean, you could imagine, okay, little spots or black and white or gray, but how does something that looks so much like an eye generate randomly? Now, the answer is, well, there's a couple of answers. One is, why does this eye exist, or this eye-like pattern, or this owl-like eyes pattern? And there, the jury's still out on that. I read a little bit of it about it on Wikipedia, and these are all of these images I got from Wikipedia. And Wikipedia, they said, look, there's two competing theories here. One theory is that this, this is, even though to us humans, the way we see things, it looks like an owl's eye, that this is actually a decoy. That this is, when some predator is about to chase wants to eat one of these things, they kind of go for the thing that looks most substantive. So instead of going for the butterfly's body, which is, doesn't look that substantive, they go for the big black thing. They say, oh, that looks like it's protein rich and it'll be a good meal. So they try to snap and bite at that. And if they bite at that, sure, the guy's wings are going to be clipped a little bit and it's going to suck. But the animal itself, the actual butterfly, would survive, and maybe it can repair its wings. I don't know the actual biology of the owl butterfly. That's one theory. And then the argument against that goes, well, no, if that was the case, then you would want the black spot even further back along its, you'd want the spot way far away from the body. You'd want it back here instead of right here, because there's still a chance if something chomps at this little black spot that it'll still get the abdomen of the butterfly. Now, the other theory as to why this exists, and who knows, maybe it's a little bit of both. Maybe both of these are true. Maybe this offers two advantages. The other theory, and this is kind of the one that jumps out at us when we see it, is, hey, this looks like an owl. Maybe this is to scare away the things that are likely to eat this dude. So maybe if, and it does turns out in my reading that they are lizards that like to eat these type of butterflies. And those lizards probably don't like to be around birds or owls because those owls eat them. So that might be deterrent. And then the other example they said is, look, they tend to be eaten by this lizard right here. This is what Wikipedia told me. And that this lizard tends to be eaten by this frog right there, and that the eyes of this butterfly are not too dissimilar to the eyes of this frog. And we can debate whether or not that's the case, and if this was the predator we're trying to mimic, you could make an argument that maybe we would have had more green on our wing. But that's not the point of this video. But it's a fun discussion to have as to what is useful about this eye. But let's have the question, how did that eye come about? And when I say that eye, I mean the pattern on that wing. What set of events allowed this to happen? Because when I described evolution, and we know that everything in our biological kingdom is just a set of proteins, and then stuff that maybe the protein but mainly protein, and that protein's all coded for by DNA. I'm going to do future videos on DNA, but DNA is just a sequence of base pairs. It's a sequence of these molecules, and we represent the adenine and guanine and then cytosine and thymine. Then maybe you have a couple of adenines in a row and some guanine and thymine. And I'll do a lot more on this in the future. But the idea is, it's just coded for by this sequence of these molecules. How do you get a sequence? How do you go from a butterfly that has no eye to all of a sudden an eye that goes there? Obviously, just one change change that happens from a random mutation, maybe that G turns into an A, or maybe this C and this T get deleted, so everything, that alone isn't going to develop this beautiful of a pattern, or this useful of a pattern. So how do the random changes explain something that's this intricate? And this is my explanation. And obviously, I wasn't sitting there watching over the thousands or millions of years as these owl butterflies emerged. So this is just my theory of how natural selection does explain this type of phenomenon. You have a world where you have, in some environment, you have butterflies. And their wings look like, let's say you have some butterflies that are generally like this. That's their wing. And it's a very bad drawing, but I think you get the idea. And there's just some general patterns. We've seen it before. There's variation. And the variation does show up from these little random changes in DNA. And I think we can all believe that most of these changes are kind of benign. Maybe they just set up differently where a little pattern will show up, or a little speck of pigment will show up with a slightly different color. And we even see amongst these owl butterflies, there is variation. This dude's wing is different than that guy's wing, with the commonality that they do have these eye-looking shapes. And there's not just one. There's actually multiple. This guy has this other thing up here that looks interesting. I mean, they have multiple things, but the one really noticeable feature is this eye-looking thing. So how do we go from this to an eye-looking thing? So the idea is you have some variation. One guy might look like that. Another guy or gal might, just randomly, their dot might be something like that. Another gal or guy, these wings are really badly drawn, but you get the idea. This is the butterfly, it's its antenna right there. That's its body. Another person's patterns might, or butterfly's patterns, might look like this, right? And so they're just random. But when they go into a certain environment, for whatever reason, maybe one of its predators, maybe that theory that these are supposed to look like eyes is true. And so actually maybe this guy just has a random pattern here. So maybe for this, and so this guy, and I'm not saying that one, it's like definitely better. They're both going to be found and killed by predators, but it's all probabilistic, right? Maybe this guy has a 1% less chance of getting a predator, because when your predator just looks at him out of the corner of that eye, that little really hazy region kind of looks like an eye, and the predator would be better off just not messing with it, and they'd rather go after the dude that looks like this. So it's just a slight probability. Now you might say, okay, what's 1% going to do? But when you compound that 1% over thousands and thousands of generations, all of a sudden, this trait might dominate. And because he's just going to be killed that less frequently, 1% less frequently. Now, maybe this guy has a similar trait, but his spot is closer to the abdomen. And here it's a trade-off, because maybe some predators get scared away by this concentration of pigment. And once again, I'm not saying that we're here yet. We're not at this kind of very advanced, sophisticated pattern yet. We're at this random concentration of pigment that just shows up. So we see that people who have this concentration of pigment further away from their abdomen, they do well. But when it's too close, maybe some predators think that that's actually an insect and they want to eat it. So that's actually a bad trait. So what happens is this guy dominates. And so within this population, you start having a lot of variation, because he starts representing he's more likely to pass on these traits. And I want to make that point very clear. This isn't what happens over the course of an animal's lifetime. It's not like if somehow I experience something, or at least our current theory, if I experience something, that I can somehow pass on that knowledge to my child. What it says is, if my DNA just happens to have just some variation that happens to be more useful or more likely for me to survive to reproduction and for my children to survive, then that will start to dominate in the population. So then the population, you're going to have variations within that. Maybe some guys, it's going to get a little bit look like that. Maybe another one's going to look a little bit like that. Maybe some spots there. You can kind of view it as the variation is quote-unquote exploring, but I want to be very clear not to use any active verbs here, because this is all being done really as almost a common sense process where everything changes. The changes that are most suited are the ones that are going to survive more frequently, and then the next generation is going to have more of that, and then you'll have variation within that change. And then this one might be like that, and maybe this is the one. These were good compared to that, but now when you're competing amongst themselves, this one is able to reproduce 1% more than this guy or this guy. And then so this guy becomes, And maybe it's some combination of all the above, and they mix and match. It's a hugely complex system. But then this guy represents most of the population. And when I say this guy, I'm saying this guy's genetic information, at least as which pertains to his wings. And then you get variation amongst that. Maybe some of it, they have a little small dot, and there's some dots around it. Maybe it's like this. Maybe one of them digresses and goes back here, but then he has trouble competing, so he gets knocked out again. And then some other people have it back here. I think you get the point that this isn't happening overnight. It's happening these changes can be fairly incremental, but we're doing it over thousands of generations. So when you're talking about thousands of generations or even millions of generations, even a 1% advantage can be significant. And when you accumulate those variations over a large period of time, you can get to fairly intricate patterns like this. So I just wanted to explain that because this is often used as, hey, how does, sure, I can believe the butterfly moth, or I could even maybe believe the examples of the antibiotics and the bacteria or the flu. I mean, because those are kind of real-time examples. But how does something this intricate show up? And I actually want to make a point here. We think this is more intricate because we can relate to it in our everyday lives. But if you actually look at a structure of a bacteria and how it operates, or what a virus does to infiltrate an immune system or a cell, that's actually on a lot more levels, a lot more intricate than a design. In fact, the whole reason why I'm using this as an example is because this is a fairly simple example, as opposed to kind of explaining the metabolism of a certain type of bacteria and how that might change and how it might become immune to penicillin or whatever else. But I want to make this very clear that these very intricate things, they don't happen overnight. It's not like one butterfly was, all of us was, completely looked like one uniform hot pink color, and then all of a sudden they have a child whose wings looked just like this. No, it happens over large periods of time. Although there might be some little weird hormonal change that does this, but I'm not going to go there. But that is possible. But I just want to make this point because I think the more examples we see, the more it'll kind of hit home that this is a passive process. We're not talking about these things happening overnight, and it's actually really interesting to kind of look at our world around us and look at ecosystems as they are today and try to think really hard about how something came to be, what it's useful for, why it might have been selected for. For example, I'll leave, are traits that occur after reproduction selected for? Well, probably not, unless they affect the reproduction of the next cycle. For example, you might say, oh, well, the trait to be nurturing after your reproductive years, that's that's after reproductive years. No, but it helps your offspring reproduce. But we already see a lot of diseases, especially once we get beyond our reproductive and our child rearing years. So once we get into our 50s and 60s, the incidences of diseases it increases exponentially from when we were younger. And that's because they're no longer being selected for, because it no longer affects our ability to reproduce, because we've already reproduced, we've already raised our children so that they could reproduce. So anything that happens at that point is now not being selected for. So anyway, hopefully this video gave you a little bit more nuance on evolution. And I want to do a couple of videos like this because I really want to make it clear that it's not making some wild claim that all of a sudden this appears spontaneously, that it really is a thing that happens over millennia and eons and very gradually.